Alright, so we're going to look at this question here. We're trying to find the area between the two functions f of x and g of x, e to the x and x take 1, between the bounds of -1 to 1 on x. So what that looks like is we have e to the x, which is our exponential function, which looks something like that. And we have x minus 1, that's just a linear function. It looks something like this. Okay, now these two functions, they don't actually ever intersect, but that's fine. That's fine. If that question was asking for the bounded area between those functions, that would be a problem, because we need those functions to cross to find some area that is bounded by those two functions. But if we're just asking for the area between them, that's fine. Now we have the bounds here from x is -1 to 1, so it's going to be from here to probably here, and it's this area here we're after. Now that is okay, let's look at how we do this. Now there's probably two ways we can look at this question. One is to find the two areas. So we could find the area here, and then we could take away this area here. That would be a negative area, which means we would be adding these two areas on. Okay? And that would be fine. But the way that I'm going to do it, the way I always do it to simplify it, is I'm going to add a new function, and I'm going to say, well, let's let h of x, if it's the area between functions, that's the difference of the areas. Okay, so h of x is going to be one of these functions take away the other function. Doesn't matter which one I take away from the other. Hands up yes. Hands up no. Okay, so no one's put their hands up at all. So let's find out. So actually, I'll just say, it doesn't matter which way we go. So we could go f of x take g of x. We could go g of x take f of x. The issue we're going to have, okay, if we just choose one at random, is that for one of them, if I go, I'll do another little diagram here while I'm doing this explanation. If I have these two functions here, I'll do one, yeah, this is fine. Let's say I find this area here. Now the area from, let's call it A and B, I'll call the top one F and the bottom one G. If I go F take G, okay, F is this whole area down to the x-axis. If I take away G, then that's going to be this area between the curves. Okay, and that's fine. That's kind of what I'm after in that question, I think. So, but if I go G take H, what that's going to give me is this area here take away this area here, which is going to be the same size, but it's going to be negative. So what can we do to our function, to our area, in order to make sure that we get the magnitude of it, but not the sign?
Absolute value.
Thank you. Absolute value. So we're going to mod the area, and that way we're going to get the size of it. We don't care about it, the sign of it. Okay, just because we're not interested in that. So I'm just going to pick one. I'm going to go, well, f comes before g, so let's say it's f of x take g of x, which is e to the x take x plus 1. Okay, so my area, my total area, is going to be the integral from -1 to 1 of my function h of x, but to make sure that I ignore that sign, I'm going to absolute value it. I'm going to mod it. Okay, now let's just work out a few things here first. What's big H? Sorry, let's do this. We will need big H in a minute, but let's start the integral first. H of x d of x, so just our normal definite integral. So we'll call it big H of x from -1 to 1, which is big H of 1 take big H of -1. This bad habit of going across. So I need big H, so big H is going to be the integral of e to the x take x plus 1 dx, which is e to the x take x squared on 2 plus x, which is, so we need h of 1 and h of -1. H of 1 is e to the 1 take 1 squared on 2 plus 1, which is e plus a half, and h of 2, sorry, not h of 2, h of -1 is e to the -1 take -1 squared on 2 take 1, which is 1 on e take a half take 1, which is take 1.5. So take 3 on 2. So let's combine these all up. We've got h of 1, which is e plus a half, take away 1 on e, take 3 on 2. So it's e take 1 on e plus 2. Now at this point, could I get an approximation in a calculator for that? Someone got that? Just because we're finding an area, it doesn't hurt to have an approximation. .35. Units squared. And that's all there is to it. So really, with these areas between curves, it's just a matter of creating a function that's the difference of those two functions, and then you just integrate across the same bounds as you would the two separate functions. I think that simplifies things a significant amount for us. All right.